Okay, today we're doing section 2A.2, which is we're going to talk about the correct order of operations. As you know, when you have a mathematical expression and you're trying to evaluate it, which means you're trying to find a single value for the expression, everybody has to do the operations in the same order. I have a couple examples here to start out. When there's more than one operation to perform in the problem, the operations must be completed in a particular order. Here in the first example, I've got the same problem written twice. Now what would happen if I did 4 plus 3 as my first operation? That would give me 7, and of course then I would have 7 times 2, and that would give me 14. Versus, what if I did the 3 times 2 first? So that would give me 4 plus whatever 3 times 2 is, which of course is 6, and 4 plus 6 is 10. I get different answers when I do the operations in a different order. So in math, we have to make sure we follow the correct order of operations so that everybody is consistent and gets the same result from the same problem, right? I had one more example here. I was squaring a number, 3 squared, right? Should I do 5 plus 3, which is 8, and then square the answer? 8 to the second power is 64. Or should I do the 3 to the second power first, get 5 plus 9, and then do 5 plus 9 and get 14. Do we know which one's the right answer? Well, we're about to find out if we're not sure. I think this should be review, but the correct order of operations is often taught using the acronym PEMDAS, right? Please excuse my dear Aunt Sally. Many people have heard. I like to write it on stair steps, because I like to consider that there are 4 steps to a problem, and you must complete each step before you move on to the next one. The first step, of course, is to do parentheses. Now, parentheses in math are used for more than one thing. Parentheses are used as a grouping symbol, and parentheses are used as a way of showing the operation multiplication. Right? When we say do parentheses first, of course, we mean using them as a grouping symbol. So what you need to do is you need to perform all operations inside any parentheses. When parentheses are being used as a multiplication symbol, they should be done when it's time to multiply. I'll get back to that in a second. The next step would be go through the problem and apply any of the exponents that need applied. Now, one of the reasons I like to write the acronym PEMDAS on stair steps is this right here. Multiplication and division gets done on the same step. Right? So you do multiplying and dividing at the same time. Move left to right. So whichever operation happens to come first, that's the one you do first. If division happens to come before multiplication, then the division gets done first, going from left to right. And the same is true with adding and subtracting. Same time, left to right. So this is what this is the order you need to do the operations in. Let's do a few examples. If you want to pause the video and try the examples yourself and then come back and see if you got them correct, I always think that's a good idea. In the first example, I am going to do the parentheses first. I'm going to do inside the parentheses first. Now, these parentheses are also being used as a multiplication symbol. I can tell that because there is a number sitting right next to the parenthesis. As opposed to the second problem, which has a parenthesis and it's got an operation, subtraction, next to it, the first problem has a number right next to the parenthesis. This tells me that it's being used as multiplication. It's 2 times what's in parentheses. So I'm not going to want to lose that multiplication operation when I do the parentheses first. I am going to do the parentheses first though, so I'm going to rewrite the rest of the problem, 5 plus 2, and then I'm going to write times 4. I like to continue to use the parentheses for multiplying. But it would be okay, as I did there, to change the parentheses to a dot if you wanted for multiplying, if you don't like parentheses being used as a multiplication symbol. So I've done the parentheses. The next step is to look for any exponents. This problem doesn't have any exponents. The next step is to look for multiplying and dividing. And of course, here's the multiplying. So I like you to rewrite the problem, but do the one operation that you're doing at a time. This would of course now be 5 plus 8, replacing the 2 times 4 with an 8. And then finally I can do the adding and subtracting, the 5 plus 8, and I get 13. In the second problem, again, the first thing I look for is parentheses. Now this problem doesn't have any parentheses. I mean, it does have parentheses, but remember, we're doing what's inside the parentheses first. And inside the parentheses, there's nothing to do. Those parentheses are just there to separate the 2 minus signs from each other. And I don't really like 2 minus signs next to each other. So when I rewrite this problem, I'm going to change the 2 minus signs to a plus anyway. And I'm not going to have parentheses. I don't like when there's 2 signs in front of a number. I'm going to change it to a plus. However, let's see. There are no parentheses to do, right? There are no exponents to do either. So the next step is to look for multiplying and dividing. And I do see some multiplying and dividing. And remember, I have to work left to right. So this is the first operation I'm going to do. That's the first multiplying or dividing I see from left to right. 24 divided by 3. I'm going to rewrite the problem, but I'm going to do this one operation. So that's going to give me 9 plus whatever 24 divided by 3 is, times 4. And notice, instead of writing minus 2, I'm going to change that to plus 2. I'm just simplifying it. I'm not doing the operation yet. All right, I have not yet finished all the multiplying and dividing, so I'm still on the step of multiplying and dividing. And the next thing I see, of course, is the 8 times 4. So I'm going to replace the 8 times 4 with 32. And now I've done all the multiplying and dividing. So now I'm ready to go ahead and do the adding and subtracting. And again, I do that from left to right. So I would first do the 9 plus 32, which is 41. And finally, I'd add the 41 and 2 together and get 43. In the last example, again, I'm going to start with parentheses. And this time I do see parentheses. There's something to do inside the parentheses. I can add the 2 and the 3 together. So I'm going to rewrite the problem, but I'm going to add the 2 and the 3 together. And this time I kept the parentheses because the parentheses have an exponent on it. now that I've done the parentheses, the next step is to do the exponent. So again, this is what I'm going to do next. So that gives me 10 plus 25. Remember, 5 to the second power means 5 times 5. And finally, I can do the adding and subtracting. The 10 plus 25 is 35. This brings me to mind one example I'd like you to see, which is not in your notes, but you could turn your notes over to the back if you wanted and write it on the back. It might look something like this. This is an example that I often see students get incorrect. The two possible answers here, you know what, I'm going to change the 3. I'm going to make it a 10 instead. The two possible answers to this problem are 6 or 14. And I often see people get the wrong answer on this because they mess up the signs. Let me explain. What a lot of people do with this is they end up with 10 plus 4 because they combine the two minuses and make it a plus, and 2 to the second power is 4. And that is not correct, and let me show you why. The first thing you have to do in this problem, according to the order of operations, is you have to do the exponent. So this is the part you're doing first. And when you do -2 to the second power, remember, that's -2 times -2. You get a positive 4. So what you actually get here is 10 minus a positive 4. So the two minus signs do not get a chance to combine into a positive sign. The minus -2 does not get a chance to combine to make it a plus because the exponent turns the -2 into a positive 4. So this is really 10 minus 4, which is 6. That is a tricky problem. All right, the last thing we need to go over then is how to evaluate an algebraic expression. An algebraic expression is just an expression that has variables in it. That's really what algebra means, working with variables. And the word evaluate is the one I'd like to talk about for a second. Evaluate means find a value. All right, it's almost right there in the word value. When you evaluate an expression, you are being asked to find a single value for that expression. So what that requires you to do is, it requires you to replace the variable with some number, then do the operations in the correct order to find a single value for the expression. So we are going to do step 1, rewrite the problem, but replace the variables. Then we're going to use the correct order of operations to find the answer. This is different than the word simplify. Simplify does not mean to find a single value. Simplify just means do any operations you are capable of doing. We'll talk about that in another day or two, I think. But evaluate. Evaluate means you got to find a single value. So in the first example, the first thing I would do is I would replace the x with 3. So I'm going to rewrite the problem. But I have replaced the 5 times x with 5 times 3. And then I'm going to do the correct order of operations. The correct order of operations would say go in parentheses and do the parentheses first. In parentheses, this would be 15 minus 4. 5 times 3, 15 minus 4, and 15 minus 4 is 11. So this is really 7 plus 2 times 11. According to PEMDAS, I would look for exponents next. This problem has no exponents. Then I would look for multiplying and dividing. And of course this one does have some multiplying. So this would be 7 plus 22. And last up, I could do the adding 7 plus 22 is 29. And I have a single value for the original expression. That means I have evaluated it. In this other one, you might recognize this formula as the formula for the volume of a box, length times width times height. And I've been given values for W and H. So again, my first step is to rewrite the problem, but replace the variables. So when the variables are next to each other, it means they're being multiplied together. L times W times H. So when I replace them, I need to put in a multiplication symbol. Because when I put there, I put them next to each other, or that'll look like the number 234, right? I need multiplication symbols in there to show those three things are being multiplied together. And this one's a very easy one to evaluate. There's really no way to get it wrong as far as the order of operations. You just need to multiply 2 times 3, and then 6 times 4. And you have evaluated that expression equals 24. Good luck.